Scientists recently scanned the brains of people who ate a specific diet for just 6 weeks. Not months, not years, 6 weeks. And what they found in one particular region of the brain stopped researchers cold. Because this wasn't some extreme experiment. These people were eating the same foods sitting in most American kitchens right now. The same snacks, the same frozen meals, the same drinks. And the changes in their brain tissue were measurable, visible, and in some cases, not fully reversible. So before you reach for that next bag, that next box, that next drive-through order, you need to hear this. Here's what most people assume. They think junk food is bad for your waistline, maybe your heart. But the brain? That feels like a stretch. That sounds like something your health-obsessed coworker says to justify their $14 salad. But the science from the last decade has completely rewritten what we thought we knew. This isn't about weight. This isn't about cholesterol. This is about the 3-pound organ sitting inside your skull, and what happens to it when ultra-processed food becomes a daily habit. The answer is more specific, more measurable, and more personal than anyone expected. First, let's define what we're actually talking about. Ultra-processed food isn't just unhealthy food. It has a clinical definition. These are products manufactured with ingredients you'd never find in a home kitchen: industrial emulsifiers, artificial flavor compounds, modified starches, synthetic preservatives, and high-fructose corn syrup derivatives. We're talking about chips, packaged cookies, flavored instant noodles, most breakfast cereals, fast food, diet sodas, and a staggering number of products marketed as healthy. Studies show that roughly 60% of the average American's daily calories come from this category. That's not an occasional treat. That's the foundation of how most people eat. And the brain, which runs almost entirely on the quality of what you consume, is responding to every single bite. Within the first 24 hours of heavy ultra-processed food consumption, something happens in your gut that most people never connect to their brain. Your gut microbiome, the trillions of bacteria that line your digestive tract, begins shifting toward inflammatory strains. This matters because your gut and your brain are in constant communication through what scientists call the gut-brain axis, a direct chemical highway that runs signals both directions. When harmful bacterial strains start dominating, they release compounds that travel up this pathway and trigger a low-grade inflammatory response inside brain tissue. You won't feel it. There's no headache, no warning sign. But at the cellular level, the process has already begun. By the end of the first week, your dopamine system starts changing. And this is where things get genuinely alarming. Ultra-processed foods are engineered, not accidentally, deliberately engineered to hit what food scientists call the bliss point, the precise combination of salt, sugar, and fat that triggers a dopamine surge stronger than what whole foods produce. After consistent exposure for just 7 days, your brain begins downregulating dopamine receptors. It literally reduces its own sensitivity to pleasure as a protective response. The result? You need more of the same food to feel the same satisfaction. And real foods, an apple, a handful of nuts, a home-cooked meal, start feeling flat, bland, almost unrewarding. This isn't a willpower problem. This is receptor-level neurological adaptation. And it happens faster than anyone wants to admit. 2 weeks in, researchers begin seeing changes in a critical area, the prefrontal cortex. This is the region responsible for decision-making, impulse control, and long-term thinking. Neuroimaging studies have shown reduced activity in this region among subjects on high ultra-processed diets, meaning the very part of your brain that would tell you to stop eating is becoming quieter. At the same time, the brain's inflammatory markers continue rising. A protein called BDNF, brain-derived neurotrophic factor, begins dropping. Think of BDNF as fertilizer for your brain. It supports the growth of new neurons, protects existing connections, and plays a central role in memory and learning. When BDNF levels fall, cognitive flexibility starts to decline. Focus becomes harder. Memory encoding slows. Mood regulation becomes less stable. And this is just 14 days in. At the 1-month mark, the cumulative picture becomes clearer and more sobering. Animal studies and emerging human research both point to structural changes in the hippocampus, the brain's memory center, under prolonged neuroinflammation. Anxiety-related behavior increases. Response to stress becomes heightened. Sleep architecture shifts because the gut microbiome disruption affects serotonin production. And roughly 90% of your body's serotonin is made in your gut, not your brain. Less serotonin from the gut means disrupted sleep signals, lower baseline mood, and reduced emotional resilience. After 30 days, you're not just looking at a dietary pattern. You're looking at a brain that has measurably reorganized itself around that pattern. Now let's address something directly. A lot of people hear this and think I've eaten this way my whole life, and I feel fine. And that's a fair pushback. But here's what the science actually shows. The brain is extraordinarily good at compensating. It masks dysfunction until it can't. The changes happening in neuroinflammation and dopamine circuitry are largely subclinical, meaning they're happening below the threshold of conscious awareness. You don't feel your BDNF dropping. You don't notice your prefrontal cortex going quiet. What you might notice is that you're more irritable than you used to be, that focusing feels harder, that you've been reaching for food when you're not even hungry. Those aren't personality flaws. Those are neurological signals. This effect isn't equal across all people. Adolescents and young adults face higher risk because their brains are still developing. The prefrontal cortex doesn't fully mature until around age 25, making it more vulnerable to dopamine dysregulation during those years. People with a genetic predisposition to depression or anxiety may see mood effects amplify more quickly. Individuals with existing gut issues, IBS, dysbiosis, leaky gut, may experience faster gut-brain axis disruption. This doesn't mean others are immune. It means some people are running this experiment at higher stakes. Here's the honest, balanced conclusion. Ultra-processed food is not poison. Occasional consumption does not damage the brain. The human body is remarkably adaptive. What the science is pointing to, clearly and consistently, is that daily, high-volume consumption over weeks and months creates compounding neurological effects that are measurable, real, and clinically significant. The good news, and this part matters, is that the brain retains significant plasticity. Studies show that dietary shifts toward whole foods, increased fiber, fermented foods, and omega-3 fatty acids begin reversing inflammatory markers within weeks. BDNF levels respond to exercise and diet change. Dopamine receptor sensitivity can recalibrate. The brain that adapted toward this pattern can adapt away from it. The real question was never whether ultra-processed food tastes good. Of course it does. It was scientifically designed to. The real question is this. When you sit down to eat, who made that decision? Was it you, your prefrontal cortex, your conscious intention, your actual hunger? Or was it a dopamine system that's been quietly rewired? One engineered snack at a time, to make sure you keep coming back? Because once you understand what's happening inside that brain scan, once you see the actual mechanism, the choice stops feeling the same. And that shift in understanding might be the most powerful thing you take away from this.